The broadcast is now starting. All attendees are in listen-only mode.
Welcome to this ISC Safety Centre webinar entitled Manage Change Before It Manages You. My name is Trish Kerin and I'm the Director of the ISC Safety Centre. Today I'll be joined by Brenda Seggerman from Tate and Lyle, my apologies. In this webinar, as with all of our webinars, if you have any questions, please put them into the questions panel and we will endeavour to answer them at the end of the presentation. I'd just like to acknowledge our Safety Centre member companies. So we have our operating and our industry partners here, and without their contribution, we would not be able to do the work that we do. We also have our supporting partners and the universities that we work with around the world to enhance process safety education for the future generation. And again, they contribute a lot to the work that we do. Now I'd like to actually introduce our speaker for the day. So Brenda works as a global process safety engineer for Tate and Lyle. She currently works in managing hazards due to combustible dust and chemical process safety in food ingredient production. She's worked in the food, power and chemical industries for over 15 years. She has a BS in chemical engineering and an MS in environmental engineering and is a professional engineer. Process safety has been a passion for Brenda ever since she was involved in a chemical release incident. This has led her to speak on process safety to the US EPA and at the AICHE Global Congress on Process Safety. She also served a term as the director of the AICHE Safety and Health Division. I've known Brenda for many years now, and I'm certainly sure that you're going to have a lot of great information provided in this presentation. It's important to note this presentation does not reflect her experience at Tate and Lyle. So without further ado, I will hand over to Brenda. Welcome.
Well, thank you, Trish. Thank you very much for that introduction. And good morning, good afternoon, or good evening, everyone, like Trish said. My name is Brenda Seggerman, and I will be speaking on the topic of management of change today. So thank you to Trish and to ISC for having me speak. I'm very honored to be presenting today on Manage Change, or It Will Manage You. And by the way, I am not the child shown in the picture. That is actually a standard corporate picture, although I am pretty sure my mother scolded me for doing exactly what this kid is doing. So it very well could be me in the picture. So just a little bit about me. Like Trish said, I work as a global process safety engineer for Tate & Lyle. I've been working in the food, power, chemical industries for 15 years, studied at Iowa State University, and most recently furthered my process safety education through Texas A&M. But most importantly, I am part of the serving staff for our rescues, and from left to right, we have Bruno, Brutus, Roxy, Meow, and Bob. Hopefully you won't hear a bark or a meow during my presentation, but if you do, now you can put a little furry face with the sound. And when I'm not working or taking care of them, I like to indulge in hockey or golf. So a little bit about Tate & Lyle. We provide products serving the food, beverage, industrial, and pharmaceutical sectors. For example, we manufacture starches that are used in soups, sauces, and puddings, as well as starches used in making paper white, and produce sweeteners such as sucralose. We are the only manufacturer of sucralose in the United States. We were founded back in 1859, are headquartered in London, and are also known for our sugar used for home baking. So Trish asked me if there were any questions I would want to put in a poll. So these are the questions that I would love to see your feedback on to better understand our audience today. So if you would please take a couple of minutes or a couple of seconds here and submit your answers to the questions if you would.
Okay, so I just opened that first poll, so waiting for results to come in. So we're getting up there. We're seeing quite high numbers of people that are involved in management of change activities, so that's really good. Okay, so I will close off this poll and show you the results. Okay. So the results that you can see there, 88% yes and 13% were unsure, with no one answering no on that one. Let's go to the next poll, which was the question that you had there, Brenda, of are you aware of the local legal requirements for management of change at your facilities? So we'll see how people answer those. Now we're seeing some different answers here to the first question, so that's always interesting. Okay, I'll close off that poll now and share those results with you. So 73% yes, 7% no, and 20% were unsure in this one. So a little bit of a different answer from the first poll to the second poll.
Okay.
Okay, and the final question that you wanted to ask our audience today, which is a fascinating question, I think. Do you ever read or look at the calories, ingredients, or any other wording on the can or bottle of your favourite beverage? And people are probably wondering why we're asking that question. So Brenda will answer that in a moment. Okay, so we're getting a very interesting result here. Very interesting result. All right, looks like they've all stopped coming in now, so I'll close that response and share the answers with you all. 100% of you said, yes, I do.
That's very interesting. Okay.
Yeah, so we'll go back to your presentation now, Brenda. Take it away.
Okay. All right. So can you see the poll questions then on that I had in my slides then?
Yep, we're back on your slides.
Okay, perfect. Thank you. Well, thank you everyone for answering those questions. Like Trish said, yes, that last question is a little interesting, but thank you. It's good to get an idea of, you know, the audience today and the involvement in MOC, and then also the awareness of requirements for MOC. So now, if you can just bear with me a little bit, a little satire on myself here. So last weekend, I had a little bit of a loss of containment incident, and, you know, kind of walk through this as we would an incident investigation, if you would. So, you know, you can see the picture of the beverage in question here on the left, and I'm certainly, you know, Tate & Lyle's not promoting this. I am not promoting this. This is just, we're just using this as a example of an incident here. So, you know, if I do my due diligence and interview the operator, who is me, so I've enjoyed this brand for many years. I grabbed the can, opened it. I have no official training in opening cans, but I would say I'm grandfathered in. So I started enjoying my beverage as I normally do. And then I saw the instructions, which you can see here in the picture on the left. I've never seen these instructions before. And as a dutiful operator, of course, I followed the instructions to a T and then spilled my beverage as I was trying to read the instructions. So let's take a look at kind of what we're at the evidence we have here. So I blew up these pictures, or enlarged the pictures on I enlarged the instructions on the can so we can better understand, better see what they say. So as you can see on the left, the picture on the left, we have part of those instructions are turned upside down. So as the instructions are upside down, and you said 100% of you said that you would read this. I'm also wondering, and I didn't put this in as a poll question, but now I kind of wish I would have, was how many of you would have turned the can upside down? Because you can see on the right, it says we know it's upside down. Why? Because the best way to drink our unfiltered cider is to shake it up first. And by turning the can over to read this, you're halfway there, give it a shake, wait 10 seconds, and enjoy unfiltered the way it should be. So it's kind of curious, you know, if you're thinking about this, how many of you, if you've already opened your can, like, oh, it says to turn it over, right? Who's going to spill it? And, you know, I can get it. You're probably thinking this person has 2 degrees in engineering, professional engineer, and we spilled the cider. But we go a little bit further on in our investigation. Why was there a spill? Well, the operator turned the open can over. Why did the operator turn the can over? Well, the operating procedure stated to do so. So why did the procedure state this? Well, because apparently it is the best way to enjoy the beverage. So And of course, I wanted to consume the beverage in the best way possible. So now obviously an MOC probably wasn't performed for this. But as you can see how a small change, and a change everyone would probably agree is for the better, can have some impacts. So, and even if a change is for the better, it still needs to be managed. And in talking with Trish about this example, there's a lot of other elements within process safety that applies to. You're talking about, communication, operating procedures, etc. But we'll just leave that for now. But another point, kind of an interesting point, is when did shaking a carbonated beverage in a can become a best practice for consumption? So, but anyway, I just kind of wanted to open up with that little satire. Lots of containment experience and an MOC example. But originally, I gave this presentation at the American Institute of Chemical Engineers Global Congress on Process Safety in April of this year. And when the session chair for the Congress reached out to me and speaking on MOCs, I asked if I should put together a tutorial on MOCs, and the chair asked that I present on my experiences and learnings with MOCs during my career. So today I'm going to present on some of those experiences I have had in my career with MOCs in hopes you will not experience the same. And these experiences include the effects of not managing a change, not properly managing the scope of the change, and not communicating the change. And for each experience, I will mention questions for you to contemplate and determine if something like what I share could happen at your facility. So just a quick review, MOC means management of change. And while changes can present risks, they are also necessary for our facilities to continue to grow and expand. So not only are we managing the change, but also managing the risk a change could pose. And some of you joining this presentation may be familiar with OSHA's Process Safety Management Regulation, also EPA's Risk Management Program, and these both require MOCs. But because of my role within combustible dust, I would be remiss if I didn't mention combustible dust. So within the United States, if you process, manufacture, produce, handle, or generate combustible dust, then you also may fall under the codes from the National Fire Protection Association, otherwise known as the NFPA. And the NFPA codes listed here all require the use of management and change for operations covered by those particular codes. You may also have MOC requirements for ISO or other quality standards as applicable to your operations. So these regulations and codes define what is considered a change. As you can see between OSHA, EPA, and the NFPA, you can see the similarities on what types of changes will require an MOC. And also Appendix C of OSHA's PSM code provides some clarity regarding what is considered a change. For example, a change in technology would include changes to production rates, raw materials, experimentation, equipment unavailability, new equipment, new product development, change in catalysts, and changes in operating conditions to improve yield or quality. Changes to equipment would include changes to material construction, equipment specifications, piping arrangements, experimental equipment, computer program changes, and changes in alarms, interlocks, and other control equipment. And I did put 2 X's in the staffing and job task column, and the link down at the bottom references an interpretation for that. So if you look at the actual OSHA code, you're not going to see that specifically called out, but from interpretations, staffing and job tasks and changes to those can and should be rolled into an MOC. So I stated the title of this presentation was to manage change, or it will manage you. And what I mean by that is that managing you is the potential for serious impacts or outcomes that could result from poorly managing a change or not managing it at all. Unfortunately, poor change management or not managing a change at all has led to deaths and injuries. Here are a couple of well-known incidents that have occurred due to ill-managed changes, but sadly, there are many more that have occurred. The picture in the upper right corner is of the disaster that occurred at Flicksborough in the UK in 1974. 30 tons of cyclohexene were released that then ignited. The ensuing explosion resulted in 28 deaths and 89 injuries. The cause of this incident was a failure of temporary piping installed in place of a reactor. The second picture in the bottom is of a combustible dust explosion that occurred at Imperial Sugar in 2008. That resulted in 14 deaths and 38 injuries. Changes were made to a belt conveyor that conveyed sugar. These changes included enclosing the conveyor and subsequently the bearings for the conveyor, but without adding proper dust aspiration to the conveyor enclosure to remove dust from the enclosure. Without aspiration, the concentration of the dust in the enclosed conveyor was greater than the minimum explosion concentration. The cause of this incident was due to a conveyor bearing that overheated and ignited the dust in the conveyor enclosure. This resulted in a primary explosion and eventually causing a devastating secondary explosion. Hopefully you never experience any of those impacts, but other impacts you could experience are shown here, and the list could go on and on depending on the operations at your site. So I started with the grim reality of what can happen if changes are poorly managed or not managed at all, but what other kinds of things can happen. So to give you an idea of what else can happen, I will present 3 experiences of what happened from a change not being managed, change not managed well, and a change not communicated. So to start with, I wanted to share an experience where change was not managed. The company I was with at the time acquired a new company with a facility that produced gallium trichloride, which at the time was used in the semiconductor industry. Gallium trichloride is produced by the reaction from flowing chlorine gas into a reactor with gallium metal in it, as rudimentarily depicted in the diagram that you see. This is normally performed in a 5 to 10 gallon glass reactor with heat applied to the bottom of the reactor to keep the gallium in a liquid state. The chlorine-gallium reaction is exothermic and generates hydrochloric acid vapors that are exhausted to a caustic scrubber where they are to be neutralized. So gallium trichloride is a high margin product, so we wanted to increase production by building a larger glass-lined stainless steel reactor, approximately 8 times the size of the smaller glass reactors. But we needed to test this new reactor out. The engineers decided to trial batches and ratios of 1:1, 1:2, and then 1:8 to determine how well the reactor would work with that amount of material and if quality specifications could be achieved. On my second visit to the site, they were trialing a batch in the new reactor at the 1:8 ratio. This reactor was located in a reactor room in the center of the facility, and also within the reactor were 20 other glass reactors, all with batches going on at the same time at various stages. This reaction to generate gallium trichloride goes from gallium chloride to gallium dichloride, and then eventually to gallium trichloride. So you're just adding chlorine atoms onto gallium. So during my plant walk around, I was in a room adjacent to the reactor room when the operator in the reactor room immediately exited the reactor room, frantically closing the door behind him. I looked through the window of the door and witnessed white vapors filling the entire room that then started to emanate from the bottom of the door into the room that I and other employees were in. We immediately started to evacuate everyone for the building and then obviously called 911. So what happened, and what you can see here, you can see a break, you see the little, looks like a red lightning bolt. So when they scaled up to the 1:8 ratio, the heat generated from the reaction exceeded the temperature rating of the glass exhaust vent inside the reactor, causing it to fail. When it failed, this allowed air into the reactor, rapidly generating massive amounts of hydrochloric acid vapors and releasing those vapors and also chlorine vapors into the reactor room. So these are some pictures from the actual incident from the local newspaper. And as you can see from these pictures, this culminated into a full-scale hazmat response. Thankfully, there were no injuries, but Shelter in place was activated within a half-mile radius of the plant. The site was not equipped, nor were employees trained to handle a hazmat response, so the local fire department actually performed the hazmat response. And they did so until all the other reactors in that reactor room were stabilized and the scene was, as secure as possible. Then a hazmat response contractor was then brought in for further reactor stabilization and cleanup. So this process continued over the course of the next month. So now all of you can just about imagine the cost of a local fire department hazmat response as well as a month-long hazmat cleanup with a contractor. So that was a very large cost. And as you probably have guessed, the red arrow in the picture in the bottom right is pointing to me. That is my backside that lives in infamy on the internet for now and forever. So there's certainly an emergency and everyone evacuated through was an emergency, but in helping to alert people from the office to evacuate on my way out, and this is not a plug for Starbucks or anything, but for some reason, I felt the need to grab my Starbucks coffee cup on the way out of the building, but thankfully I did because that is all I had to use to write notes on during this incident. We all evacuated, left everything, and I had to make the call to the National Response Center, and that was the only means to record, regulators that showed up, who I talked to, and the time of that call that I made. So, car keys, purses, notebooks, everything was left inside, when we evacuated the facility. So in the top picture on the top right, you can see the white vapors emanating. So we overwhelmed that caustic scrubber. And so, that was another reason for the half-mile shelter-in-place radius. Because of the location of this facility, this disrupted the train in between New York City and Boston, and also disrupted traffic flow in between New York City and Boston. So this had a pretty large impact and received a lot of media attention right off the bat. So how did this change manage us? Well, as I mentioned before, thankfully there were no injuries, but as you can see, there were many losses and costs associated with this change. During the incident investigation, we discovered that no MOC had been performed. Training on the site's MOC policies had not been formed, and no one was aware the MOC had not even been performed. So the site was covered for PSM for chlorine, but the engineers working with the experimental reactor were not aware of the MOC requirement. So, and because no MOC had been performed, no hazard assessment had been performed to evaluate any potential exothermic reaction or effects on the system. So you may think that everyone knows when an MOC needs to be performed, but making sure of this is very important before something like this could happen at your site. And as for how this change managed me personally, this is a day I will never forget, and I'm very thankful I'm here today to be able to share this experience with you. So, and you see some of the questions that I have posed here. An MOC should have been performed. Well, are MOCs being performed for changes that are occurring at your site? Are employees trained on your MOC policies? And do employees understand when an MOC should be performed? So there's a couple of questions, to kind of think about your experiences with MOCs at your facilities. So my second experience I would like to share involves a system comprised of what you see here. This drawing is certainly not to scale or to, it's a very rough diagram, let's put it that way. But it was originally designed to produce one product that uses a chemical card called epichlorohydrin. And epichlorohydrin, as you can see by the NFPA diagram here in the bottom right, is very toxic and also flammable. And this is a batch process that would start in reactor 1, proceed to reactor 2, and finish in tank 1, where epichlorohydrin should no longer be present. If a batch in reactor 2 required rework, it could be sent back to reactor 1. But tank 1 was only supposed to use during this process and was otherwise isolated especially when reactor 1 or reactor 2 were running other products. So during this process, only one material was to be transferred to tank 1. The valve to the thermal oxidizer, which you see here on the diagram, would be open, so any remaining epichlorohydrin vapors would be routed appropriately to a thermal oxidizer. So just for a little bit of clarification, tank 1 is an atmospheric storage tank with a rupture disc that was vented outside the building. So because this is a batch tolling facility, you always want to have the ability and the flexibility to produce new products. So a new product was going to be produced solely in tank 1, but in doing so, this would need to be sent back to reactor 2. So in order to accommodate this, the piping arrangement needed to be added between reactor 2 and tank 1 is indicated in the diagram by this orange flow arrow that you see. Mind you, this was a change in the original flow path. To do this, a new actuated 4-way valve was installed under reactor 2, and this replaced an existing actuated 3-way valve. So since the whole system was down, other changes were made to reactor 1 and 2 at the same time. One MOC was performed for all of these changes, since the intent was for all of the changes to be finished at the same time. But this was true until the production schedule changed, and the reactors had to go back into the service to produce the epichlorohydrin product. The only thing left remaining was to install a new selector switch for the 4-way valve. The selector switch would allow the operator to select where they wanted the flow to go. But because that couldn't be completed before needing to start backup, the decision was made to close out the changes to the reactors on the MOC and pause on finishing the new selector switch until after this current production one was completed. As far as everyone knew, the 4-way valve was safe because the new selector switch hadn't been installed. The old one was still in place, so the valve could still safely be used for 2-way directional purposes. The only thing is that no one informed the electrician of the reactors being restarted and tank 1 sitting idle. So the electrician went ahead, did what they were supposed to do. They installed the selector switch, the new selector switch, which looked identical to the old switch, unbeknownst to the operators. So when they restarted this batch, the batch in reactor 2 was found to not be within specification, so it needed to be transferred back to reactor 1 for to be reworked. This was a normal part of this process, and the operators followed the operating procedures to use the selector switch to send the material back to reactor 1. Unfortunately, they unknowingly set the switch to go to tank 1 via the new piping route instead of back to reactor 1. And approximately 14 hours later, loud noise was heard in the processing area. So, like I said, unbeknownst to the operators, the electrician had installed the new selector switch. So when the operator thought he was selecting to transfer from reactor 2 back to reactor 1, he was in fact transferring the contents from from reactor 2 to tank 1. As the material from reactor 2 was inadvertently transferred to tank 1, remaining epichlorohydrin vapors were coming out of the material, and this caused the pressure to increase inside the tank. Because the material was supposed to be transferred to reactor 1, this also meant the valve to the thermal oxidizer was not open on tank 1. So pressure continued to generate in tank 1 until the rupture disc burst, which released epichlorohydrin vapors outside the plant. So thankfully, there were no injuries. No operators were exposed to epichlorohydrin vapors. The vapors did not ignite, and tank 1 did not rupture because the rupture disc properly relieved the tank. This, as you're probably well aware, this is a very significant incident for us. We, in a sense, we overpressurized a vessel, and thankfully the last layer of protection, that rupture disc, worked as it was supposed to, or we could have had an explosion, could have had a fire, We could have employees injured from tank rupturing or employees exposed to epichlorohydrin. And obviously this could have been a very bad situation, but thankfully no one was injured from this incident. And also we're very thankful there are no offsite impacts from this release. Because thankfully the amount of epichlorohydrin released to the atmosphere, well, it did not trigger a notification to the National Response Center. And like I said, there are no offsite releases, but we did have to report the release as an air permit violation to the state. So after the incident, there's a large amount of downtime to perform internal and customer required investigations, replace the rupture disc, and also clean and evaluate the integrity of tank 1. And some of you may be thinking, well, a pre-startup safety review, otherwise known as a PSSR, should have been performed. Well, a PSSR was performed for the changes made to reactors 1 and 2, but since the work had not been completed on tank 1, the PSSR for those changes had not been completed yet. So, if we're looking at scopes of MOCs, how do you manage the scopes of your MOCs? Some people like to put a large amount of changes within one MOC, and a lot of people some people like to do maybe smaller amounts of changes on an MOC, or separating them into multiple MOCs. So you think about how the scopes are your MOCs managed. What about when the scope changes? How are those scope changes communicated to employees, to contractors, or anyone else who may be involved with that system? Are multiple changes combined into one large MOC, or are they separated into multiple MOCs? And my last bullet point here, the process should have been properly locked out to prevent any flow going to tank 1. But if we think about how we did this, we closed out the MOC for reactors 1 and 2. We did the PSSRs for those, and we didn't really touch the system that was newly installed because we really didn't think there was going to be any issues, because everyone had the thought in their mind that the old selector switch was still in place, and that would have also prevented flow from going to tank 1. So we didn't take that extra step to think, hey, maybe we should just lock this out just in case that selector switch failed. So my last example involves an anhydrous ammonia tank showing up to the plant one day. Due to an increase in orders, production was being increased for a process that used ammonia. Instead of having a truck provide the ammonia, the engineering department made the decision to purchase a bulk storage tank to store ammonia on site. So this would mean no more scheduling trucks for production, would have ample on-site storage, and the benefits went on and on. But one day, the EHS person in charge of the facility air permit performed a plant walk around and discovered this 10,000-gallon storage tank on site. The tank was just sitting there, not connected by any piping, but per state air regulations, just the tank being on site and not connected to any process was considered an activity that required a construction air permit. Since the EHS person had no knowledge of the tank being ordered, no construction permit had been applied for. Because no construction permit had been obtained, technically the tank had to be lifted back onto a flatbed truck and stored off-site until the construction permit was received. Thus, this delaying the project and production of this particular product. So there was no release of toxic material, there was no injuries, but this change still managed us by having to seek out an expedited and certainly more costly construction permit, and then the project being delayed until the permit was received. And this caused missed customer delivery dates, very angry customer. But the one good thing was the delay gave us time to revise our risk management plan for the site to accommodate the larger increase in the amount of ammonia being on site, perform the proper analysis of the hazards, and update all necessary response plans. But as you can see, this is a pretty tricky situation, right? Thankfully that EHS person performed that walkthrough and saw this tank. Otherwise, there could have been a lot of issues surrounding just the tank being started up and operated. But when you think about your MOCs at your facilities, are the appropriate stakeholders, are they part of performing MOC? Who is reviewing your MOCs and who is approving them? You know, some companies will have engineering, they'll have quality, they'll have production and safety, you know, but somehow the safety part was not completed for this MOC. And how are MOCs communicated at your facilities? This wasn't a particularly large facility. That's a pretty large tank to just show up someday. So, you know, kind of in the back of your mind, how are MOCs communicated at your facilities? And how are increases in chemical amounts managed? How are new chemicals managed at your facility? So through my experiences, I've tried to share with you my experiences involving MOCs and some takeaways from these experiences. I talked about what I experienced when no MOC was performed because of the lack of awareness of an MOC being required. And as elementary as it sounds, the importance of defining what changes require an MOC is very important, and making sure people are aware of when MOCs need to be performed certainly could have prevented the incident involving gallium trichloride, as well as the loss of jobs to those employees in that community. So does your MOC policy state what is considered a change, and are your employees following through with that policy? And the second experience, you know, I just discussed involved multiple changes being covered under one MOC and that scope changing. And while it's always great to try to either reduce paperwork, try to combine things as much as possible, the more changes in an MOC means the change will need to be managed more closely to prevent things from slipping through the cracks, especially if changes happen to conclude at different times covered within that MOC. So how do you manage the startup of different parts of a system safely within one MOC? How is this being communicated to your operators and your contractors? And then lastly, I discussed the importance of communication of change and having appropriate stakeholders part of the MOC awareness and approval process. You think, how could a 10,000-gallon tank just show up and no one in your EHS department not know about it? But if the communication is not there, it can certainly happen. So thankfully, none of these incidents resulted in deaths or injuries. But hopefully from the experiences I've shared, you can see how changes, if not properly managed, can manage you in other ways. And lastly, don't let change manage your beverage. So here are some resources that may help in understanding more about managing change. And then Trish, you may have some other ideas for resources and management of change from IChemE. But that is the end of my presentation. If you'd like to connect, here's my email address. And with that, thank you for attending today, and I will turn this over to Trish.
Great.
I welcome any questions or comments.
Okay, thanks for that, Brenda. As I said when I first heard this presentation, I think 3 excellent examples of what can go wrong when we don't get management of change just right. I've got a couple of questions here. The first one's from Anna. How to create awareness on people that they need to follow an MOC process. My experience tells me that people want to do the right thing, but most times they don't know they need an MOC. Do you have any sort of tips that you could talk about in terms of how you work on getting over that hurdle? Because it is quite a common hurdle that people don't often know they need to do something.
Well, I think first it really starts with, you know, what regulations apply that drive that MOC requirement, especially from the process safety side of things. If the facilities in the United States, and I would say if you're covered under EPA or OSHA process safety management or EPA risk management plan, you know, understanding what they consider, what changes they consider that would require an MOC, and really look at that and then base that on your operations. A good example that I've used here personally within Tate and Lyle is working with our quality group. The question came up, well, if we change bags that contain our starches or sugars, you know, this is a combustible dust. That type of change really, that shouldn't need a management of change. Like, well, if we go back and we look at the NFPA codes, it does specify if you happen to change materials or packaging materials, that does require an MOC. So really understanding the requirements that drive when an MOC is required, and then understanding within the operations of your site where you could have changes that fall under those definitions of change, and really start driving it through that. You could work through developing a policy, and also, performing some training to go through, from our site, from our regulations. These are areas that would require an MOC.
Mm-hmm.
So,
okay, yeah, because I think one of the things that I've seen a lot of is we often get a debate occurring in facilities around, but it's a like-for-like change. And, where that definition lies between like-for-like and actually a change. So just because something does the same job does not mean it's like-for-like. And we can often see MOC incidents occur as a result of that. Got another question here, one from Dan. So a follow-up question to are MOCs being performed for changes that are occurring at your site could be, how do you know competent MOC reviews are being performed for changes that are occurring at your site? Do you have any comment on that as sort of one of those questions to really think about, making sure that you've got the right reviews being done?
No, I think part of that is really pulling in the correct stakeholders for who you want to review those changes. For sure you'd want to have your EHS personnel involved in those MOC reviews. Maybe some upper level engineering support as well. Quality is always helpful as well. And kind of based on the change, who needs to be the stakeholders, reviewing those MOCs. And I guess I'm assuming that's kind of the initial part of the MOC, or are we kind of talking about the back end of the MOC?
Yeah, I think it's part of the scope being defined as well up front, that when you know what the scope of it is, then you can figure out what reviews need to be undertaken and by whom at that time. Yep. Okay. Next question is from Katerina. How do you suggest obtaining assurance that the MOC approvers have the right skill set, i.e. knowledge, competence, training, to approve the change?
That's a really good question. I would have to say is from experience, especially in regards to the experience that I talked about with the anhydrous ammonia tank showing up on site, that particular EHS person, they manage, it's a Title V air permit at the site, and they manage that. So any involvement in any changes that impact air emissions whatsoever, that person was certainly involved because they had very intimate knowledge of the air emission regulations and how any changes would impact the site. Mm-hmm. So you can kind of rely on, like from their specialty, kind of what they do, what their job is, that can kind of rely on that. They're going to know that. From an engineering perspective, if you have a change that involves a relief valve, I would want to make sure that you have someone then on that MOC that is reviewing the calculations associated with relief valves, the relief design basis, to make sure you're adequately covering all the scenarios in which a relief would be needed, as far as a fire impacting a tank, or if there's potential for a polymerization of the material in the tank. Those are aspects that need to be considered. So it also, I think, going back to what Trish just said, the scope of the MOC, and then kind of getting an idea of who your experts are within the company and pulling them in on that MOC review.
Yeah, I think I'd probably also add that as an example, in the Safety Centre, we've published a guidance document on the different levels of competency, different roles in an organisation need to have from a process safety perspective. So I'd sort of make sure that the people that are doing your MOC review and approval activities are meeting some of those competency requirements that are relevant as we defined in that guidance document that we published 2 years ago now, with the supplementary guide of how to achieve the competence as well. So I think that's probably a good resource for people to take a look at, that they can find on the Safety Centre website. Just a comment from me, I guess. One of the things, as you were going through the case study where the selector was changed, the selector switch was changed out and that wasn't communicated, it actually reminded me of one of the things that occurred in an incident several years ago. And I think from memory, it was in LaPorte in Texas, and there was a rupture disc in the pipework, and the rupture disc had an alarm on it that would go off if the rupture disc ruptured. But it was very unreliable, so the operators had become used to ignoring it because it was just unreliable. And at some point in time, the technology on the rupture disc was changed out, and it was changed out to a very reliable rupture disc. And when it did give the alarm that the disc had ruptured, it really had ruptured, and it released, I believe, methyl mercaptan, and there was a fatality as a result of that. So the CSB have got a report on that particular incident. So an example of when people don't realise that something has changed around them, it can have very fatal consequences in those instances as well, because the operators didn't know that the change had been made, and so they had come to ignore an alarm because it was a nuisance false alarm all the time, except for that one time that it wasn't a nuisance false alarm, and they discovered that the hard way.
Oh, that's a really good example, Trish.
Yeah, so the other part that I found interesting was in your first example. So it really impacted the Porsche dealership next door as well, with all that chlorine in the air.
It did.
I can imagine that was an expensive activity, and as you said, the facility ended up closing down from that perspective. So yeah, so there's certainly been a lot of really interesting aspects here. We've got one last question come in now from Michael. How do you manage emergency MOC requests? It's important to maintain the integrity of the MOC assessment without taking too much time. It's also not easy to maintain the definition of an emergency. What are your thoughts on that one? You're in the middle of the night and you've got to make a change. What do you do?
We're actually kind of working through this with one of our current facilities, and kind of taking a look at what kind of emergencies could we have at the site that could prompt an emergency MOC. And granted, you're not going to cover everything, but you'll probably cast a wide enough net to cover the majority of situations. So you can kind of pre-plan a little bit. If you can, what if I have, like for the example, if we have a leak of epichlorohydrin, all right, that could result in an emergency MOC. How are we going to deal with that? Because you can deal with the change and then do the paperwork later, but if you can kind of brainstorm and try to gauge what kind of emergencies could we have, that may be a good start, a good place to start to kind of, like I said, kind of figure out little pre-plans ahead of time and how to address that.
Yeah, good point. So, that's really similar to if you've got a structured procedure to deal with a particular scenario, then it's not really at that point of management of change as such. It's actually following a structured procedure, even though it may change something. Provided you've done the assessment on generating the procedure, then you've gone through the different assessments that need to be done and the approval process there, I guess. So, emergency response plans are effectively that, where things are changing dynamically, but you've got a plan to deal with it. Okay, well, thank you very much for that. I think as we've seen in this webinar that management of change is a critical part of the safety of your facility, whether you are managed under OSHA PSM, or whether you are in another part of the world where we use a safety case regime, management of change is still a critical element of any safety case regime around the world as well, and management of major hazard activities. So regulators all over the world expect management of change to be adequately done, and not only from the hardware change, but also a lot require the staffing changes of personnel, changes of organisation. Typically, in my experience, I think organisational changes is perhaps even more poorly dealt with than equipment change. And you did actually highlight the staffing and job task changes in your table earlier as well. So there's certainly a lot to focus on in management of change. I hope you all found that useful. Brenda, do you have any closing remarks?
No, I don't think I'm, just thank you everyone for your questions and attending. And if you have any questions, feel free to reach out. And thank you again for attending.
Great, thank you. So as you can see on the screen, and I've got a typo in my slide, I apologise for that. Why is it you never see the typos until it's on display in front of everybody? We're still working on our 2022 webinar schedule, but you can take a look at our website to see what webinars we have coming up. And if you could just move to the last slide, please, Brenda. My contact details are on the screen. Check out what we've got happening at the Safety Centre at our website, and please follow what we're doing on social media, where you will find regular updates of what's going on in the world of major hazards management, as well as our incident anniversary series. There's been actually one question. Brenda, could you quickly pop back to slide number, the one with the books on it? Management of change books. We just had one last question come in asking for that. So it would be slide 27.
Does it come up on the screen?
No, I've currently got slide 25. So if you go forward another 2. No, we might actually be, that's it, perfect. Okay, so back on.
Okay, I'll stop clicking now.
So all 3 of these books are from the Centre for Chemical Process Safety, which is part of the American Institute of Chemical Engineers. Auditing for Process Safety Management Systems, Management of Change for Process Safety, and Managing Process Safety Risks During Organisational Change. And I guess the other CCPS book that does talk about management of change and introduce it as a requirement is Guidelines for Risk-Based Process Safety, which is sometimes known as the Red Book, which is the CCPS overall management of process safety management standard. Great. Well, thank you all very much. Wish you all a safe day. Please stay safe, and I look forward to bringing you more webinars in the new year. Have a safe and merry festive period. Thank you, everybody.
Thank you, Trish.